Assalamualaikum and hi, we are from Group A. We will present about geometric distribution. My name is Sharifah Sakinah binti Abdul Hamid, 2027X6. Next.
My name is Nur Haifa Julia binti Muhammad Johaidi and my matrix number is 202604.
Next.
Hi, my name is Hain binti Ismail and my matric number is 200277.
And my name is Clarence Lewin Champion and my matrix number is 203240.
So I will explain about geometric distribution. The definition is geometric distribution is the number of trials needed to get the first success in repeated Bernoulli trials. So from this equation, GXP, X is the number of trials and P is the probability of success equals to probability of success and the Q is probability of failure and to the power of number of trials minus by 1. So there is 4 conditions in geometric distribution. First is each observation is one of 2 possibilities, which is either a success or failure. Number 2 is all observations are independent. Number 3, the probability of success P is the same for each observation. And fourth, the variable of interest is the number of trials required to obtain the first success. So we move to the equation. I will pass the presentation to the Haifa.
Okay, so for geometric, now I'm going to present about the geometric distribution formula summary. First, we have probability mass function, which is Px equal to K equal to P times 1 minus P power of K minus 1, which P is actually the probability of success, K is number of success. 1 minus P is actually Q, which is the probability of the failure. So then we have cumulative distribution function. Next we have mean, which is mu equal to Ex, expected value, equal to 1 over P, which is probability of success. And then we have variance equal to sigma squared equal to Vx equal to 1 minus P over P squared. From the variance, we can have the standard deviation, which we just have to move the square to the right hand side of the equation. Then we have the standard deviation equal to square root of 1 minus P over P. Next, we have the graphical representation of the geometric distribution. From here, we can see that the graph is inversely proportional with the parameter of probability of success. From here, we have 3 graph of probability of success with value of 0.2, 0.5, and 0.8. The graph will change based on the probability of success parameter. Next, moving on to Ain.
Okay, thank you, Haifa. So now we will look at the example question of geometric distribution. We will go through example from lecture notes and real life situation. And I will explain the example from lecture notes and Clarence will explain the example from real life situation. This is the example from lecture notes. The question goes, in a certain manufacturing process, it is known that in every 100 items is defective. What is the probability that the 5th item inspected is the first defective item found? So to solve this question, we will let X be the number of trials required to produce the first defective. Using the geometric distribution with X equal to 5 and P equal to 0.01, we will have G 0.01 minus 0.01 times 0.99 to the power of 4, and the answer will be 0.0096. We just have to substitute the value into the equation that have been explained by Sakina and Haifa just now. So moving on.
Now, I will explain on the real life example. So before I proceed to give one example, I will explain generally on the practical uses of a geometric distribution. So there are 3 types of general practical, where the first is scenario analysis. In scenario analysis, so we are finding several distinct possibilities for the outcome of particular event. So after finding out these distinct possibilities, these possibilities will be then compared to each other. And the second practical uses is sales forecasting, where a lot of business person will use this sales forecasting to predict future sales together with scenario analysis. However, this precise value for future sales cannot be predicted, but the flow can be understood well. And for the third practical uses is risky evaluation. It is to evaluate any possible risk to determine what is the outcome and chances of taking a particular risk. For example, an architecture trying to build a design of a building. So they use this risky evaluation to evaluate the probability of any possible risk found. So in the next slide, I will give you a real life example. So the real life example is a practical application. I took a spot analysis where my teammates just explain on the Bernoulli trials. So to give a rephrase of Bernoulli trials is where the first success can be found on the number of trials. So let's say in sports, particular in baseball, geometric distribution is useful in analyzing the probability of a batter to get a hit before he or she receive 3 strikes. From this real life example, the goal is to reach a success within 3 trials. So let's say a coach teach a specific hitting method where the method will cause the baseball player to have a 30% chances of getting a hit on any given pitch. So ignoring balls, so the probability that the player earns a hit before he or she strikes out, which requires 3 strikes, is shown below. So in this below formulation, or the calculation is on the general formula that was explained by Sakina. So we have 0.7, which is the probability of failure, whereas the 0.3 is the probability of success of getting a hit. So let's say on the third, the success reached at third hit. So after calculating the probability of the player earns the hit would be 0.65. But this is generally formula calculation. Now, in the next slide, we'll show you more in depth of where if the coach hitting method can cause a hit on the third trial, and find the probability mass function, mean variance, and standard variance, where px is equal to 3 and success of hitting is 0.3. Now, this time I will use the formula that was explained by Haifa. So the probability mass function, based on the formula, so we just plug in using the given data, which is px is equal to 3 and the success of hitting is 0.3. So when putting in the data into the formula, so you will get the probability mass function, which is equivalent to 0.147, and you round it off and you will get 0.15. Now, to find mean, it is 1 divided by the number of by the probability of success. So since the probability of success is 0.3, so 1 is divided by 0.3, and therefore you will get 3.33 as your mean. And the variance is 1 minus 0.3 divided by 0.3 to the square, to the power of square. So you will get 7.77, which equivalent to 7.78 after rounding off. And lastly is to find the standard variance, which is square root of variance, and you will get 2.78, and you round it off to become 2.79. So this real life example is just a manual calculation. If I'm a coach, so we use a manual calculation to find this probability mass function, mean variance, and standard variance. That's all from my part. Thank you.
Thank you.